Let us start chapter 2 and have a lot of fun. We're going to learn about statements and operations between statements. Very well. So when it comes to math and especially logic, we try to separate English statements from mathematical and logical statements. We say that, hey, those statements are the ones that we want to work with, that we can assign truthfulness or falsehood to them separately. Definition of mathematical statement. A mathematical statement is a sentence which is true or false, not both. A mathematical statement is a sentence which is true or false, not both. We usually denote a mathematical statement by P, Q, R, and so on. We denote a statement by P, Q, R, S, T, and so on. For example, I say, hey, 2 plus 2 is 5. Is this a mathematical statement? Of course. You can easily verify if it's true or false. Even though it's false, but it's still a mathematical statement. Okay, so we define something, and now we want to expand our knowledge, expand the definition, see what we can do here. What is our goal? Our goal is to connect mathematical statements together and be able to analyze the truth or falsehood of these compound statements. So this is our goal. We want to construct new statements and analyze them. So remember, when you start talking about numbers in algebra, you define some operations, some connectors to actually build some new numbers. Addition, subtraction, multiplication, division, and so on. Here you have statements, mathematical statements. We need some new operations to actually connect them together. The very first operation that we're going to talk about is negation. Then we're going to connect two statements together by and then by or. And finally, we're going to use implication to use two statements connected together by implication. So we are defining some operations for connectors to form compound statements. The very first one is negation. This is the symbol that we use for negation. If you open different discrete math books, you might see this notation as well. So both of these are representing negation, not. Negation, or read as not. It's not the case that, not. Another connector is called conjunction. Conjunction or wedge operator, meaning and. Upside down wedge is disjunction. We read it as or. So negation, conjunction, disjunction. Now we're going to talk about implication or conditional by using an arrow. Implication, if, then. Finally, we're going to talk about biconditional connector as well. Double arrows. So this is biconditional. If and only very well. So remember that our goal is to analyze a statement. Is it a true statement or is it a false statement? Which one is that? We have some operations. These connectors are actually helping us to connect statements together and construct something more complicated than before. We are going to use truth tables that helps us to analyze truth and falsity of statements. Truth tables help us to analyze compound statements. So let us begin. For negation. Remember that the negation of a statement is denoted by not P, or you can write it as not P using this symbol. Both of them having the same meaning. Since you have just one statement, you can assign two values to that statement. This statement is either false or it is true, not both. So our first column have all the possible values for P, and the second column actually shows what is the value of the negation of P. If your statement is true, its negation is going to be false. That makes sense. If the statement is false, its negation is going to be true. This is easy, not that hard to follow. What if we have conjunction? Conjunction P and Q. Here we have two statements. We need to consider all possible combinations of the values for P and Q. P can be true, Q can be true, Q can be false. P can be false, Q can be true, Q can be false. So let us start. We have P, we have Q, and we have a compound statement, P and Q. All possible combinations. True, 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 false, false, true, false, false. We define conjunction this way. You see that when we have conjunction, conjunction is true if and only if both of the statements are true. True and true is true. The rest of them are just false. True and false is false. False and true is false. False and false is also false. So this is for conjunction. Disjunction. P or Q. What if we have or? How do we define the truth table for or? Let's take a look at this. We have two statements, P, Q, so we get four combinations, 2 to the second power. P, Q, P, or Q. Okay, P true, Q true. You consider all possible combinations. P true, Q false. P false, Q true, P false, Q false. It happens that disjunction is false if and only if both of the statements are false. For the rest of them, it's going to be true. True or true is always true. True or false, it's true. False or true, it's true. And it is false if and only if both of the statements are false. Next, implication. P, then Q. If P, then Q. This is interesting. So, since we have two statements, we have four combinations. We have P, we have Q, P, then Q. Okay. P can be true, Q can be true. P can be true, Q can be false. P can be false, Q can be true. P can be false, Q can be false. We define implication this way. If P is true, then Q is true. The statement, the compound statement is true. If P is true, Q is false. If your hypothesis is true, your conclusion is false, the outcome is always false. However, if the hypothesis is false, but the conclusion is true, this is always true. If the hypothesis is false and it implies a false conclusion, then it is true. So for biconditional, the last connector is defined this way. Biconditional. P, if and only if Q. It is true if and only if P and Q, both of them are true or both of them are false. So let's write this down here. We have P, we have Q, we have P, if and only if Q. So let's use green. We have true. P might be true, Q might be true. P true, Q false, P false, Q true, P false, Q false. So biconditional connector is defined as it's true if and only if both of these two statements have the exact same value. True and true gives you true, false and false give you true, but in other cases, it's going to be false. Give us an example. Well, if you have less than 3 statements, it makes sense to use truth tables. But eventually, we're going to learn about laws, how to use those laws to simplify our compound statements and actually analyze the value of the compound statement. Let's take a look at one example here. So example says construct the truth table construct the truth table for the compound statement, which is defined this way: Q or Q and not P and Q. Okay, well, how many statements do we have? Original statements. We have P and Q. The rest of them are compound statements. So we have 2 original statements. P and Q. Well, how many combinations do we get? We get 4 combinations. If you had 3 statements, it's going to be 2 to the 3rd power or 8 combinations. So since they have only 2 statements, they have 4 combinations. So let us start. We start by writing the first and second column, P, Q, true, 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 false, false, true, false, false. Okay, perfect. Now, we have to get back to the compound statement. I'm going to start from parentheses that we have. The first parenthesis that we have has quantity P or Q. So I'm going to number this by 1. And I'm going to write down 1 here. Okay, P or Q. What we have learned so far is that the combination of P, Q using or is going to be false if and only if both of the statements are false. So it is false and the rest of them are true. Now what I'm going to do, I'm going to go to the next parenthesis. I have P and Q. Let us number this for simplicity 2. I'm going to write down 2 here. P and Q. We know that P and Q is true if and only if both of them are true. So true, true, you get true, and the rest of them are false. Now take a look at this. You have negation in front of 2. So let us number this guy 3. 3 is the negation of 2. The negation of 2. So the negation of true is false. The negation of false is true, true, and true. And finally, what I'm doing, I'm combining 1 and 3 using and. So my last column is going to be 1 and 3. 1 and 3. So I can ignore the rest of these. 1 and 3, I only need 1 and 3. True and false, false. True and true, true. True and true, true. False and true, false. So this is the truth table or the value for this compound statement.